All right, so in 42, you have 9x plus 3 times x minus 4 equal 10 times x minus 5 plus 7. All right, so if this is on your test Thursday, what's the first step you're going to show me? Distributive property. All right, so you're going to distribute twice. And so the next thing you're going to write will be 9x plus, and then 3 times x minus 4 will give you what? 3x minus 12, okay, equal. And then 10x minus 5 will give you minus 50, and then plus 7 on the corner. And get the keys. The keys are right here. Okay, so that will be the first thing. Then what are you going to do next? Combine like terms. So on the left side, what are you going to write? 12x minus 12 equal, and over here, 10x minus 43. Okay? All right, then what's the next step? Say it again? I didn't hear you. The addition property of equality. The addition property of equality. So it does not matter which side you bring the variables on or the constants, but let's deal with the variables first. Do you want to bring the variables to the left or the right? To the left? All right, so what step would you have to show if you want to get all your points? Well, let's deal with the variable first. Let's deal with the variables first. Okay, is adding 10x going to help? No, you're going to have to subtract 10x. Adding 10x is not going to help because 10x plus 10x is 20x. So you want to subtract 10x from both sides. And this is how it needs to look. So you're going to line your like terms. And now what's the next step? Okay, what is that? Combine like terms, what we're using. Okay, you got to say combine like terms. So 12x minus 10x is 2x minus 12 equal. Now what's going to be on this side? Yeah, because 10x minus 10x is 0, and you get negative 43. Those of you that just walked in, make sure you turn in the worksheet as soon as you get settled. Okay, what's the next step? Add 43 to both. Well, I wouldn't add 43 to both sides, which you could, couldn't you? You could add 43 to both sides. There's nothing wrong with that. I'm going to show you what's going to happen. I would not do that. This is what you're going to be doing. Y'all agree that this is mathematically correct? All right. And then combine like terms again, I get 2x. And then on your calculator, what's a negative 12 and a positive 43? A positive 31. And then over here, that's 0. You got to put 0 there on the corner. And then get the keys right there. But then what do you have to do if you do it this way? Subtract 31 from both sides. But why didn't you do it here instead? So instead of over here, what should you have done? Add 12 to both sides. You'd save yourself maybe 1 or 2 steps. Okay, so here you add 12 to both sides. And then combine like terms, you get 0 here, so that's 2x, equal on your calculator, a negative 43 and a positive 12 is a negative 31. And then what property am I using next if I keep on with this one? Multiplication property of equality. So what do I have to do to both sides? Divide both sides by 2. It's got to look like this. And then 2 divided by 2 is 1. 1 times x is x, and this is your answer. Negative 31 over 2. That's your solution. Okay? Now, those of you, a few of you that did this, what would be the next step if you continued on with this? Subtract 31 from both sides. And then combine like terms. I get 2x equal negative 31, which is what this was right here. And so the next step is to divide both sides by 2, and you still get the same answer. You still get the same solution. Okay? All right. All right, so it's number 42. All right, and then let's look at one more with this. Okay, making this up. Let's write this example. Okay, so on your test, what if you had this? I'll write this example. Okay. What was that? How are you gonna do? Okay. Yeah, and then remember, a common error that some people make is they're gonna say 4 minus 2 is 2 and distribute the 2. You can't do the subtraction. You have to do what first? Multiplication. So you have to distribute first. So you have to distribute the negative 2. And over here, distribute the negative 3. So you get 4. And then what would this become? Minus 2x minus 14 equal, and then minus x, right? Okay, what's the next step? Combine like terms. And on this side, when I combine like terms, what do I end up with? Minus 10, okay, good. Over here, what do you end up with? Minus 18? Okay. All right, then what's the next step? And let's deal with the variables now. Do you want to bring the variables to the left or the right? The left, that's fine. What are you going to do to both sides? Add 4x to both sides. All right, now some of you have a habit of just saying add 4, and you'll notice that a few of you in that worksheet that you got back, you said add 4, add 4. You're not adding 4. You're adding what? 4x. So you need to make sure you're adding 4x to both sides. Because if you just say add 4, those are not like terms to begin with. Negative 4x and 4 are not like terms. So you got to say add 4. So notice there's, I don't know if y'all helped each other, but about 3 of you had the same errors. It's fine if you help each other, and then one of them erased the x's. So I'm not sure why. But try and understand why that x is needed. I mean, that you're adding 4x. You're not adding 4. You're adding 4x. So it is needed there. And now I can combine like terms because these are not like terms. A 4x and a negative 4x, those are like terms. In fact, they're opposites. So when I combine like terms, this is 0. And what's a negative 2x and a positive 4x? 2x minus 10 equal. And then what's left on the other side? Okay. Now be strategic. Don't go in a circle like a couple of you did in the previous problem. What's going to be the next thing you're going to do? You got to get the variable term by itself. Add 10 to both sides. And then align your like terms. Okay, so these are opposites, so when I add them up, I get 0. So I get 2x equal, what's a negative 8 and a positive 10?
Negative 18.
Yeah, negative 18 and a positive 10. All right, and then finally, what's the last step you're going to show me? Yeah, show me this. And I need to see that you're using the multiplication property of equality. So x equal negative 4. Okay? All right. And then some of you had an issue with something like this. Suppose you had 6 minus 2x minus 3 equal 6 plus 7x. All right, so what are you going to do? Okay, so you got to remember that this right here is understood to be a negative 1. So if you need to, put that negative 1 there, and then distribute the negative 1. So in distribute the negative 1, we get 6, and what's going to be the rest of these terms? Minus 2x plus 3, because a negative times a negative is a positive, equals 6 plus 7x, that's a 7. Okay, what's the next step? All right, when I combine like terms on the left, what do I get?
2x plus 9.
Negative 2x plus 9 equal 6 plus 7x. Okay, so I have variables on both sides, constants to the other. We got to bring the variables to one side, constants to the other side. So let's bring the variables to the left. It doesn't matter. I just want to bring it to the left to see what you would do. So if I bring the variables to the left, what are you going to do to both sides? Subtract 7x. All right, and then combine like terms. A negative 2x and a negative 7x is negative 9x. Plus 9 equal, this is 0, and you're left with 6, right? Okay. What's the next step? Subtract 9 from both sides. And I end up with negative 9x equals a negative 3. What's the next step? Divide both sides by negative 9. All right, and then negative 9 divided by itself is 1. 1 times x is x. All right, you also have to remember that a negative divided by negative is a positive, and the directions noticed on the worksheet said simplify or reduce your answer. So it'll be positive 1/3. Positive 1/3. Okay? All right, and then now there's one or two problems from the study guide that said you would see something like this. So what if you had negative 2/5 x equal, I don't know, I'm making this up, let's say it was 10. All right, what are you going to do to both sides? That was from a previous section. That was divide by what? Okay, negative 2/5. All right. So right now, multiplying by negative 2/5, the opposite of multiplication is to divide. So you divide by the coefficient. So you would say divide by negative 2/5, divide by negative 2/5. And this is what I'm talking about when on some of your comments. Some of you left that division symbol off. It needs to be there. All right, and the negative 2/5 divided by negative 2/5 is 1, and then you just got to figure out what this is. So from a previous course, 10 is 10 over 1. So when you divide fractions, you change the multiplication problem. So that becomes 10 over 1 times what? Negative 5 over 2. And then you can reduce. 2 into 2 is 1. 2 into 10 is 5. And then what do you get? Negative 25. So that was that one where it says show that one step. That's that step you have to show. Then you do your work and you say x equal negative 25. That's what you would show.
Multiplication by the reciprocal from the get-go instead of having to divide it.
Yeah, so the other way that we did this was this way. So the other way was to multiply both sides by the reciprocal. All right, so the reciprocal of the coefficient was the reciprocal of negative 2/5. Negative 5 over 2, so you would show that. All right, so you can either do it this way or you can do it that way. All right, and then notice that this right here is going to be what number? 1. 1 times x is x, and then that's 10 over 1, and then you reduce. And so you get negative 25. Yeah, negative 25. Okay, so either way is fine. All right, we did it both ways. Okay. All right. And then the other thing you got to be careful with is when you had something that just looks like this. All right, now, before I go on, what if one of the questions says, what is the coefficient of d divided by 6? So let's say the coefficient of d. So what's the coefficient of d? 1. It's not 1. It's 1/6. All right, we talked about that because you can write d over 6 or d divided by 6 as 1/6 times D. That and this are the same thing. So the coefficient of D is not 1, it's what? 1/6. Okay? So what's the coefficient of X right here? Negative 1/2. You see, we just talked about that. Some of you still said 1. It's not 1, it's 1 over -2 or negative 1/2. So what you may want to do when solving this equation, and this is the way that they did it in those two sections. In the section 9.3, we're going to see that you can clear your fractions. We're about to do that, but the way we did it was this way. And then you could do one of these two things. You could divide by the coefficient, or you could multiply by the reciprocal. So which one do you want to do? Multiply by the reciprocal?
Yeah.
So what's the reciprocal of negative 1/2?
2/1.
Negative 2 over 1. You got to say negative because the negative times the negative is a positive. But what I do to one side, I have to do to the other. And this negative 2 over 1 divided by 1 times negative 1/2 is what number? 1. 1 times x is x. And then what's 6 times a negative 2? Negative 12. Okay? All right. Okay, now, let's look at something that has a fraction in it. So this is going to be number 18. Now we're going to do 18 two ways. So we have 4/5 x minus 8/5 equal a negative 16/5. Now this could have been in section 9.1 and 9.2. Because if you notice the denominators are the same. So it's not that bad to do what we did in 9.1 and 9.2. So there's only one variable term, and it's here. So, but I have constants on both sides. So based on 9.1 and 9.2, one of those worksheets you turned in, what from the last class period or even from this one, what are you going to do to both sides? Add 8/5 to both sides, okay? You can do it just like this. Right, and then 8/5 divided, a negative 8/5 and a positive 8/5 is 0. So you get 4/5 x equal. All right, now we have a negative 16/5 plus a positive 8/5. So it's a negative 6, and remember the denominators are the same. All right, so they're the same. Huh? Negative 8/5, okay. And now that kind of looks like one of the problems you just did. So do you want to divide both sides by 4/5 or multiply by the reciprocal? Multiply by the reciprocal. So what's the reciprocal of 4/5? Right, and then 5/4 times 4/5 is 1. 1 times x is x. All right, over here I can reduce. 5 and a 5 is 1. 5 and a 5 is 1. 4 and a 4 is 1. 4 to negative 8 is a negative 2. So what's x? Negative 2. That's x. All right, so again, you could have done this from a previous lesson. But let's talk about the idea of clearing the fractions. Let's talk about it that way. So in this lesson, in section 9.3, when you have fractions, they want you to clear the fractions. Okay, clear the fractions. So there may be some directions that's going to say clear the fractions. So you got to show that you're clearing the fractions and not what we just did. So what we just did is not clearing the fractions. So let me show you what clearing the fractions mean. Okay, so your steps are the same. So all the steps that we did, remember the first step is to, if you have parentheses, get rid of the parentheses, use the distributive property. Then you simplify by combining like terms. Then we use the addition property of equality, combine like terms, and then always the last step was what property? Multiplication property of equality. All right, so if you have fractions, though, the first thing you want to do is clear your fractions. All right, so step 1 would be clear fractions. And you're going to do that. You're going to do that by multiplying both sides by the LCD. So by the LCD. All right, and so we're going to look at a problem that involves clearing the fractions, which is the one we just did. So let's do the one we just did again. So this is going to be 18 again, but we have 4 fifths x minus 8 fifths equals a negative 16 fifths. All right, so if you look at this, I do have fractions. You can see them because they all have denominators. So we have at least one fraction here, and I can see that denominator. In fact, there are 3 of them. All right, so what is the smallest number that will go into 5, 5, and 5? Or let me ask this. What's the smallest number that 5, 5, and 5 will go into? 5. Says at least common denominator. So at least common denominator is 5. Okay, now what you want to do is you want to get rid of those denominators. So you're going to clear the fractions, and we're going to use multiplication. So you can multiply both sides by that LCD. All right, now you see the left side has 2 terms? The left side has 2 terms. You're going to put that in parentheses, and you can multiply by 5, just like this. It'll look just like this. The right side only has 1 term, so you don't need parentheses. In fact, I wouldn't put parentheses, just 1 fraction. So just rewrite it over. But remember, what you do to one side, you have to do to the other. So if I multiply the left side by 5, I've got to multiply the right side by 5. All right, so that was my step 1. So step 1 is to multiply both sides by the LCD. All right, so you got to find the LCD first. In this case, it's easy because they're all the same. Since the left side had 2 fractions, 2 or more fractions, put that in parentheses and put the LCD in front. The right side only had 1 term, so you don't need parentheses there. Leave it off, and then times 5. Now I have parentheses though, right? Before I didn't, now I do. So now I've got to get rid of that parentheses. So what's step 2? Okay, just let's put clear the parentheses. By using distributive property. All right. Okay, so in section 8.7, you had the distributive property. You have to use distributive property to simplify expressions. So you did stuff like this. So in your mind, you're saying 5 times 4 fifths x. So 5 times 4 fifths. Remember, 5 is 5 over 1, right? So if you look at the 5s, I can divide those out. So what is this expression right here equal to? No, say it again. 4 what? 4x. So 5 times 4 fifths is 4, but what's 5 times 4 fifths x? 4x. Okay, minus. All right, then we're going to say 5 times 8 fifths. 5 times 8 fifths. So if you're doing this correctly, the denominators, you see when I cross these out, I put a 1 there. The denominator is going to be a 1. So when I cross this 5 out, I am going to get a 1 because that 5 can reduce with this 5. And so what's 1 times 8? 8. So this becomes 4x minus what? 8. Okay, equal. And over here, if you think about what you have here, I'm going to just go ahead and rewrite this. The 5s divide out, and what are you left with? Negative 16. And the 5s have to divide out. That 5 in the denominator, I have to replace it with a 1. Because that was the whole purpose of multiplying by the LCD, is to get all these to be 1s. And so now I've cleared the fractions, and so now that looks like previous types of equations that we've had. All right, so I have this linear equation. So to solve a linear equation, you bring the variables one side, constants to the other. So I already have the variable term on one side. What's the next step? Move the constant to the other side. So how you can do that? Add 8 to both sides. And then combine like terms. So the next step, So what step did I just use here? The addition property of equality. All right, so once we clear the parentheses, using distributive property, we combine like terms. Remember that? So we simplify by combining like terms. And then we were using the addition property of equality. All right, and then we also, once we do that, we'll always combine like terms. All right. Okay, so I add 8 to both sides. So I'm using addition property of equality. Now I'm going to combine like terms. So negative 8 and positive 8 is 0. So I'm left with 4x equal, and what's on the other side? All right, and then finally, what's the next step? Multiplication property of equality. Multiplication property of equality. All right, so what do I need to show, though? Yeah, guys, say divide by, divide by. What am I dividing by? 4. 4 divided by 4 is 1. So what's x equal to? Negative 2. So x is negative 2. All right. Now, it was much quicker for this case now. Wasn't it much quicker just to do this? Yeah, but it's only because the denominators are the same. All right, but there'll be a lot of situations where it is easier to clear the fractions. Now, this one wasn't, so it's much easier to have done it in what we learned before, only because these denominators were the same. Here, it's a little bit more work that you have to do. Okay, now let's look at this. So this is going to be number 54. So this is probably an example where clearing the fractions is more helpful. So you have x divided by 5 minus 7 equals x divided by 3 minus 5. So I have fractions. Okay. Now, right off the bat, the directions, the step says this. The step says clear the fractions. That's what the step says. So let's do what the step says. Clear the fractions. So I got to find the LCD. Now, technically, how many terms do you have altogether? 4. There are 4 terms. There's this term, x divided by 5. There's this term, negative 7. There's this term, x divided by 3. And there's this term, negative 5. This term right here has what denominator? 5. This term that I'm pointing to has what denominator? 1. This has what denominator? 3. And this has what denominator? All right, so of those 4 numbers that we just mentioned, what's the smallest number that these 4 will go into? 15. Okay, so the LCD is 15. Okay, so then you're gonna multiply both sides by 15. But notice that if you go back to the previous problem, I had to put some parentheses, and you put parentheses around a side if it has more than one term. So see, this has how many terms? 2. This has how many terms? 2. So I'm going to put those in parentheses. And then I'm going to say times what on both of them? 15. So that was your step 1. So you've shown step 1. So step 1 is this. All right. Now, step 2, I have parentheses. So what's going to be the next step? Distributive property. So you're going to say 15 times this, 15 times this, and same thing over here. So you may have to do some work on the side so you don't mess up too much if you do it in your head. You got to be careful. So you have 15 times x divided by 5, right? That's what this is. So it's really 15 divided by 1. If you need to put that 1 there, put the 1 there, and now reduce. Remember, the whole purpose of clearing that, of multiplying both sides by the LCD is to make this 5 what kind of number? You want a 1 there. You want a 1. And you will, because Because when I reduce, what's 5 divided by 5? 1. 5 divided by 5 is 1. What's 15 divided by 5? And so what is this expression right here? 3x. So what is 15 times x divided by 5? 3x. Okay? Minus. And what's 15 times 7 on your calculator? 105? All right. Equal, and now we'll do the same thing here. You're saying 15 times x divided by 3. So remember, I want to get rid of this 3, and what number do I want there? A 1, and I will, because 3 divided by 3 is 1. 3 divided by 15 is 5. And what is this expression? 5x. So what is 15 times x over 3? 5x. And then what's 15 times 5? Negative 5. Negative 75, is that right? Negative 75? So we have 5x minus 75. All right, so I clear the fractions. All right, and then the rest is just what we've been doing. So I have this linear equation, so let's bring the variables one side, constancy the other. So you want to bring the variables to the left or the right, does not matter. The left. All right, now notice if you bring the variables to the left, you're going to end up with what kind of coefficient? If you bring to the right, you would end up with what kind of coefficient? Okay. All right, let's bring it to the left. And then combine like terms. What's a positive 3x and a negative 5x? Okay, minus 1 over 5 equal. Combine like terms, that's 0. And what's left on the other? Negative 75. What's the next step? Okay, add 1 over 5 to both sides. And then combine like terms. So I get negative 2x equal 30. Okay. And then finally, what property do I use next? Multiplication property of equality. So I'm going to divide both sides by negative 2. And then negative 2 divided by negative 2 is 1. 1 times x is x. And what is my solution? Negative 15? Okay, negative 15. So that's your solution.
I do have a question.
Uh-huh.
If you decided to take, like, from the original problem, and you have x over 5 and x over 3, if you decide to do the 1 over 5x, and you still want to distribute property?
Yeah. So her question's this. If you rewrite it, so remember a while ago, one of the problems I said if you had 1/5 x minus 7, x over 5 minus 7, that's really 1/5 x. So she wants to write it like that. So she would say 1/5 x minus 7 equals 1/3 x minus 5, right?
Yeah.
Okay, and so the LCD is 15. So you would still do the same thing. All right, and so the only difference, instead of saying right here 15 times x divided by 5, you'll say 15 times 1 over 5x. Okay, which is the same thing. 5 and 5 is 1, 5 and 15 is 3, and you get 3 times 1 times x, which is 3x. Okay? Yeah, no, that's, you can do that, that's fine. So this, again, you'll get 3x minus 105. I'm not going to do it, it's the same equation. And same thing here, you'd say 15 times 1/3 x. 3 to 3 is 1, 3 to 15 is 5. 5 times 1 times x is 5x. Okay? All right. Okay, now let's look at this one. So this is all right, so this is 62. All right, 62, you have 5/9 x plus 2 minus 1/6 x equal 11/18 x plus 1/3. All right, so you have a lot of fractions here. How many terms on the left? 3. How many terms on the right? 2. So on the left, this denominator right here is what? This denominator is 1, because that's 2 divided by 1. And this is 6. This is, and this is 3. So it's the smallest number that those numbers go into? 18. So the LCD is 18. And so to follow the steps we're doing, you're going to put both of those in parentheses, just like this. And so there's that 1/6. So instead of saying minus x divided by 6, now you see you could have put this as minus x over 6, right? But you all know now that minus x over 6 is the same thing as saying negative 1/6 x. Okay, so then what do I have to multiply both of these by? Okay, so that's the first thing you're going to show me. You're going to show me that. So that's going to be on test 2. That's what you would show. And then what's the next step? Distribute. All right. So in the first, on the left side, I'm going to multiply those 3 terms by 18. And on the right, I'm going to multiply those 2 terms by 18. All right. So you may need to do some work on the side, though, unless you're pretty good at multiplying fractions. You have 18 times 5/9. That's what I have. So when I reduce, remember the whole purpose is to get rid of that 9. You want a 1 there, and you, if you're doing this correctly, you will. 9 divided by 9 is 1. 9 to 18 is 2. So that'll be 10, correct? So what is 18 times 5/9 x? 10 what? 10x. Okay. Now what's 18 times a positive 2? 36. And now let's do some work here. So it'll be minus, and okay, now 18 times 1/6. 18 times 1/6. So 6 and 6 is 1. 6 and 18 is 3. So that's 3. So what's 18 times 1/6 x? All right, so do you all agree that down on the left side I get 10x plus 36 minus 3x? So I've cleared my fractions on the left. All right, on the right, I have 18 times 11/18. So if you do this correctly, you got to get a 1 in that denominator. So 18 divided by 18 is 1. 18 divided by 18 is 1. So that's just what number? 11. So what's going to be that term, though? 11x. And then finally, 18 times 1/3. 18 times 1/3. So 3 and a 3 is 1. 3 and 18 is 6. So you get 6. So it'll be 11x and then what? Plus 6? Okay. All right, so that's where we're at. So we got rid of the fractions. That's what we end up with. So you can easily mess up around here, but try not to, because the rest is now easy. Because you just keep following the steps we've been doing. So what's the next step? Combine like terms, and I can combine like terms on the left. So it's 10x and a negative 3x. Okay, so 7x plus 36 equal 11x plus 6. All right, you want to bring the variables to the left or the right? The left? All right, so what are you going to do to both sides? Subtract 11 what? X. Say minus 11x. And I'm aligning my like terms. And then I'm going to combine. So what's 7x minus 11x? Negative 4x. Plus 36 equal, and then that's 0 here. And then you're left with what constant? Okay? And then finally, what's the next step?
Subtract 36.
Okay? And then combine like terms. So I get negative 4x equal negative 30. And then divide both sides by negative 4. All right, so negative 4 divided by negative 4 is 1. 1 times x is x. And remember, negative divided by negative is a positive. And then reduce, so 30/4 is what fraction? Okay, that's that 7.5 is a mixed number. What fraction, though, is it? 15 halves. 15 halves. All right. So now, if you wrote it 7.5, that's fine. But if they say leave it as a fraction, then just leave it as 15 halves. Okay, so you can write it as an improper fraction, or you can write as a mixed number. See, that's a mixed number. This is your improper fraction. That's your fraction. All right. Okay, now, all right, let's look at this one. Okay, so this is going to be number 24. All right, so in 24, you have 3 times y plus 3 divided by 5 equals 2y plus 6. Okay, so let's talk about the right side. On the right side, how many terms do you see? 2. Now, on the left side, you see that there's that one fraction you see, right? So think of this as one term, although you can do some stuff to it and write it in separate terms. But for right now, the way it looks, I see just one little thing, this one fraction. See it? There's a numerator and then there's a what? Denominator. Over here, that 2y, I see a fraction. 2y is my numerator. What's my denominator? 1. That's 6. That's a fraction. My numerator is 6. My denominator is 1. All right. So altogether, I have how many terms? 3. So 1 and then 2 altogether. So this denominator is what? This denominator is 1. So what's the LCD? 5. Okay, now the way you're going to do this, just like you've been doing, is you see the left side, there are more than one term, so you can put that in parentheses. Okay, just like we're doing. But since that's just one fraction right here, leave it as it is. Don't put that in parentheses. It's just one thing. So leave it as it is. But then you also have to multiply both sides by what now? So you can say times 5, just like this. Okay. Now there are several ways you can do this. So the right side, that's easy. You're going to use what property? Distributive property. So on the right side, you're going to get what expression? 10y plus 30. Okay. Now let's talk about the left side. So you see the whole purpose of multiplying by the LCD is to clear the fraction, correct? So you see that 5? That 5 better reduce with the LCD. So you're going to say 5 into 5 is 1, 5 into 5 is 1. Okay? And now you're going to say 1, this 1 times this 3 is what? 3. So you can distribute a what? A 3 here. So that's what you can distribute. Okay? So when I distribute the 3, what do I get on this side? Plus 9. And then the rest is like the others. Okay, so you want me to bring the variables to the left or the right? Which side? The left. So you're going to subtract 10y. So it's 3y minus 10y plus 9 equal. And then what's over there? 30. What's the next step? All right. And they combine like terms. I get negative 7y equals 21. What's the next step? Yeah. Now remember, you divide by the coefficient. I saw some of you divide by negative 7y. Never divide by the variable. Always divide by the coefficient only. So negative 7 divided by negative 7 is 1. 1 times y is y. And what's your solution? Negative 3. All right. Now what if you had this? Similar to this one, but let's say it was this problem. So let's say you had 4 times x minus 2 divided by 10 equal 6x divided by Let's make it 5x. 5x divided by 6 minus 2. So write this example.
Yeah, 5 or 6.
Huh?
On the right side, 5 or 6.
That's 5x divided by 6. Let me change this right here to just, let's say 7. Make that 4 7. Okay, what's the LCD?
30.
30.
Okay.
Now, could someone had multiplied both sides by 60? Yeah. All right. You would have to, you would end up with bigger numbers, which at the end you would have to reduce. All right, but you could use 60. 60 is a common denominator. But what's the least common denominator? 30. Because the smallest number that 10, 6, and 1 go into is 30. 10 goes into 30, 6 goes into 30. So we're going to use the least. So the least is 30. And then multiply both sides by 30, just like I did with number 24. So it's going to look like this. The right side, I have to put that in parentheses. And I'm going to leave this as the fraction. All right, then we say times 30 times 30. Okay, so now I'm going to distribute on the right side. I'm distributing the right side. So when I do that, you may have to do some work on the side. That's 30 times 5 over 6. Remember, doing this correctly, that 6 has to become a 1. So 6 into 6 is 1. 6 into 30 is 5. And what's 5 times 5?
25.
So on the right side, what's 30 times 5, 6x? 25x. And then what's 30 times a negative 2? Negative 60. So that's what you get on the right side, 25x minus 60. Now when we reduce on the left, though, right here, remember the whole idea, the whole purpose of multiplying by the LCD is to clear your fractions, your denominators. So 10 into 10 is 1, 10 into 30 is 3. All right, so remember how I use the distributive property here? You're going to use the distributive property here, but what number are you going to distribute? 21, not the 7, but a what? 21, because 3 times 7 is 21, so that's what you're going to distribute. All right. So what's 21 times x? And then what's 21 times a negative 2? All right, so that's what you get. All right. Okay, so in both cases you had parentheses, you distributed, but be careful with the left because previously that was a 1, and then 1 times 3 is 3, so that's why we just distributed 3 because that was a 1. But here it's not a 1, it's a 3. 3 times 7 is 21, so you distribute the 21. And then the rest is like we've been doing. Do you want to bring the variables to the left or the right? So what are you going to do to both sides? Subtract 25x, just like this. Combine like terms. What's 21x minus 25x? Okay, minus 42, right? And over here, when I combine like terms, these are opposites, so they have to be 0. And what's left? Negative 60. A couple more steps and you're done. What's the next step? Add 42 to both sides. Then combine like terms again. So I get negative 4x equal negative 18. Then what do I do to both sides? Divide both sides by negative 4. Negative 4 divided by negative 4 is 1. 1 times x is x. Now remember, negative divided by negative is a positive, but you got to reduce. So what's 18/4 reduced? 9/2, or if you want to rise a mixed number, it will be what, 4.5? All right. Okay, so that's how you clear the fractions. Then remember in the previous lesson you had stuff on decimal. So let's just do something with a decimal. This is number 28. Use your calculator when you have those decimals. All right, so in 28 you have 0.60 times z minus 300 plus 0.05z equals 0.70z minus 205.
It's 2 minus 30.
That's 300. That's a z. Z. That's a z. All right, so we're going to use distributive property. So 0.6 times z is 0.6z, right? Now, what's 0.6 times? No, really, it's 6 tenths. I keep saying 0.6, but it's 6 tenths. So what's 6 tenths times 300 on your calculator? Negative 180. Plus, and this is 500ths z, so 0.05z equal. So all I did was distribute property. So I'm writing everything else over. And you see that how was 0.70? I just wrote as 0.7 because 0.70 is the same thing as 0.7. Okay, what's the next step? Combine like terms. So 0.6 and 0.05 is 0.65 z, is that correct? Minus 180 equal 0.7z minus 205. All right, what's the next step? What do y'all think? Okay, so subtract 0.7 from both sides. Now use your calculator. What's 0.65 subtract 0.7? 0.65? Negative 0.05? Okay, but it's be negative 0.05 z. Okay, minus 180 equal negative 205. All right, what's the next step? All right, combine like terms, you get negative 0.05z equal, what's that, negative 25? All right, and then finally, what's the last step? Divide both sides by negative 0.05. And so negative 0.05 divided by itself is 1. 1 times z is z. On your calculator, what's 25 divided by negative 0.05? Is it 500? Yeah, because a negative divided by negatives will be a positive, so it has to be a positive number. So 500? That's your solution. So you do it the same way you did the previous worksheet with decimals. You use a calculator. All right. Okay, now let's look at this. All right. Okay, suppose we had this. Okay, this is number 30. So we have 14x plus 7 equal 7 times 2x plus 1. So 14x plus 7 equals 7 times 2x plus 1. What's the first thing you're going to do? Distribute, okay? Distributive property. So we got 14x plus 7 equal, and then 14x plus 7. All right? Then what are you going to do? Keep doing what you were doing. What are you going to do? Subtract 14x from both sides, okay? All right, subtract 14x from both sides. Then you combine like terms, right? And so that's 0. So what's left on the left? 7. What's left on the right? 7. So what do you notice happened compared to everything else you've done? So there are no variables, right? So no variables. The variables disappeared this time. Whereas in the past we had a variable as our last statement, z equal 500. So my solution was 500. Here we had x equal a third. So my solution was a third. Here I don't see an x. I don't see an x at all. But I want you to notice something. If I go back to the original, I'm going to ask you, is 0 a solution? So remember there was a previous worksheet where you had to show whether a number was a solution or not? And so the question is 0 a solution? What did you do to determine that 0 was a solution? Where we saw the variable x, you plugged in 0. So here you'd say 14 times 0 plus 7, and you want to see that's equal to 7 times 2 times 0 plus 1, right? Well, what's 14 times 0? What's 0 plus 7? Okay, over here, what's 2 times 0? And 0 plus 1 is 1, and 1 times 7 is, are those equal? Yeah, so 0 is a solution, right? Okay, here's my next question. Is 2 a solution? Is 2 a solution? Let's do the same thing. 14 times 2 plus 7. So where we see an x, what I'll plug in? 2. All right, so 14 times 2 plus 7. And we see that's going to equal on the left side. On the right side, I get 7 times 2 times 2 plus 1. The right side is easy to figure out. What's 14 times the left side? What's 14 times 2? 28 plus 7 is 35. Over here, let's do parentheses first. What's 2 times 2? 4 plus 1? 5 times 7? So they're equal, right? So would 6 be a solution, do you think? Yes. Would negative 8 be a solution? Negative 2.6? Yes. So you see the statement right here where it says that 7 is always equal to 7. Is that a true or false statement? Is that a true or false statement? Is 7 always equal to 7? That's a true statement. So if the variables go away, and you have a statement that's true, then that means that no matter what you plug in is going to be a solution. So your answer is going to be all real numbers. All real numbers. Okay, any number works. You saw I did 2 of them. I did 0. I let x be 0. I let x be 2. If you use 6, if you use negative 1/2, all these numbers are solutions. Okay. Now remember we said we solved this equation. The variables disappeared, right? What kind of statement is this? True. So what are you going to write as your solutions? Our numbers. And you can see that any number would work. If you go back and plug some numbers back in. Okay. Now, what if you had this? Almost done. What if you had this? Okay, making this up. Suppose we had this. Suppose we had 14x plus 7. Let's make this 8. 14x plus 8 equals 7 times 2x plus 1. So 14x plus 8 equals 7 times 2x plus 1. What do you have to do first? Distribute. And so I get 14x plus 8 is equal to 14x plus 7, right? And just like we did before, you would probably say I'm going to subtract 14x from both sides, correct? Combine like terms. But what statement do you have left, though? And is that a true or false statement? That's a false statement. So that means that, remember when we went back and we said, let's see if 0 works, 2 works? If you go back, nothing works. So if you try 0, what's 14 times 0? 0 plus 8 is 8. If you plug in 0, what's 2 times 0? 0 plus 1? 1 times 7? 0 doesn't work. If you plug in 2, it won't work either. Nothing works. So if the variable disappears and the statement is true, what are your solutions? What are you going to say? Our numbers. If the statement is false, you're going to say this. You're going to say no solution. That's what you're going to say. Okay. All right. So in my math lab, there are a couple like those where the variable disappears. So you're either going to say no solution or all real numbers. Okay. All right. So let's see. You had 9.3. I gave you 9.3 less. No, I gave you 9.3.8, right? Okay. So that's not due until Tuesday. Not due until Tuesday. This is 9.3a. So let's look at the directions. So let me tell you what the direction says. So look, 9.3a. All right, 9.3. Notice, what do you see in your problems? And there are 4 of them all together. So don't forget, there's a front side and a back side. What do you see there? Fractions. It tells you got to multiply both sides by the LCD. Okay, you got to show that. So that won't be due until Tuesday. Here's the one where, now notice it says this. All these problems, you're either going to get no solution or all real numbers. All right, but you got to show that step where you get that false statement or true statement. Okay? Use those 2 examples we just did. And then this is just the one with the decimal. That's all it is. But don't forget there are 4 of them though. Don't forget their back page. All right. So I'm put that up.
All 4 problems on this page?
Yes.